How does Netflix recommend the perfect movie? How does a bank approve or reject a loan within seconds? How does your inbox catch spam before you even open it? These may seem like completely different problems, but many of them are solved using the same machine learning algorithm, the decision tree. So, what exactly is a decision tree? Imagine you're trying to make a decision by asking a series of simple questions. Every answer helps eliminate possibilities until only one final answer remains. That's exactly how a decision tree works. Instead of making random guesses, it asks one question at a time. Each answer determines the next question, and this process continues until the algorithm reaches a final prediction. Because of this structure, it looks like an upside-down tree. Now let's understand the different parts of this tree. At the very top is the root node. This is where the decision-making process begins. It asks the very first and most important question because every other decision depends on it. From the root node, the tree splits into child nodes. These nodes receive information from the node above them and continue the decision-making process by asking additional questions. Any node that has one or more child nodes connected to it is called a parent node. Finally, we reach the leaf node. A leaf node doesn't ask any more questions. It simply provides the final prediction or decision. All of these nodes are connected by branches. Each branch represents the answer to a question, yes or no, and guides the data toward the next step in the tree. That might sound technical, so let's understand it with a simple real-life example. Imagine your friend asks, "Should I carry an umbrella to school today?" The decision tree starts with its first question. Is it raining? If the answer is no, the decision is immediate. Don't carry an umbrella. But if the answer is yes, the tree asks another question. Is the rain heavy? If yes, carry the umbrella. If no, you probably don't need one. Notice what happened. The decision tree never jumped directly to the final answer. Each question reduced the number of possibilities until only one decision remained. And that's exactly how a decision tree makes predictions. Now let's move to another important concept: binary classification. The word binary simply means two. Whenever a decision tree predicts between exactly two possible outcomes, it is performing binary classification. Some common examples: yes or no, pass or fail, spam or not spam, true or false, 0 or 1. The algorithm simply decides which one of the two classes the input belongs to. But here's something many beginners don't realize. A decision tree isn't limited to just two classes. It can classify data into multiple categories. Instead of predicting only pass or fail, it could classify fruits as apple, mango, orange, or banana. And it can also work with numerical values: age, salary, exam scores, temperature. Decision trees handle numerical data just as well as categorical data. That's what makes them one of the most versatile algorithms in machine learning. But now comes the most interesting question. If a decision tree learns by asking questions, how does it decide which question should come first? Why does it ask, "Is it raining?" before, "Is the rain heavy?" How does it know which question provides the most useful information? That is the real intelligence behind a decision tree. And the answer lies in two powerful concepts: entropy and information gain. These concepts help the algorithm choose the best possible question at every step, allowing it to build an accurate decision tree from scratch. We'll explore both of them in the next video. If you found this video helpful, don't forget to like, share, and subscribe to Neural Stories. Because every algorithm has a story. And here at Neural Stories, we make sure you understand it. Thanks for watching, and I'll see you in the next video.